today we're going to go over graphing quadratics in vertex form. So when you have vertex form, it's just one parenthesis with the exponent here. So that's how you'll be able to distinguish it from the other two forms. The A, the number out in front right here, tells us how our graph opens. So if A is positive, your graph's going to open up. If A is a negative number, your graph's going to open down. So A also tells you how wide or narrow your graph is. As you can see in the equation, it says minus h right here. So that means that whatever you see, it's going to be the opposite, and you're going to be moving left and right. And k just says plus, so it just moves your graph up and down, and it's exactly what you see. So now, in order to graph it, the first thing you're going to want to do is to identify your vertex, the hk. So it's going to be the opposite of the inside number and your outside number. So for this one here, my vertex is -9, 5. And then the next says you want to choose an x on either side of the vertex. I always choose a number above and a number below, just one above and below the vertex. So in this case here, I'm going to plug in -10, and then I'm going to plug in -8. And you're going to actually plug that into the equation, like -8 plus 9 squared plus 5. And when you calculate that, you should get out 8. When you plug in -10 into the equation, you should also get out 8. So then your last step was just to plot all three of those into a U. I'm going to go by twos. 2, 4, 6, 8, 10, 2, 4, 6, 8. So -10, 8, -8, 8, and then -9, 5. So that parabola right there would be your solution. So now let's try another one. So the first thing I notice on here is that my A is negative. So that's going to make my graph open down. So when I'm done, my graph will be going down, or I messed up somewhere. My vertex for this one is -3, 4. Remove the opposite of the inside, comma the outside number. I'm going to pick a number one smaller and one bigger. I'm going to actually plug that into the equation. So you plug in -1/2, -2 plus 3 squared plus your 4. And plug that into your calculator or your head. And either way, you should get 3.5. If you plug in -4, you have to get the exact same y value because it's symmetric. And you're going to plot those dots. I get 1, 2, 3, 4, 1, 2, 3, 4. -4, 3.5. -3, 4, -2, 3.5. Sorry, that one ran into the notes there. So you see it's pointing down, so we know that we did it right. So let's have one more example here. This one, my vertex is going to be 1, 3, number opposite of the inside. A number bigger and smaller, so 0 and 2. Plug those into the actual equation there, 2 minus 1 squared, 3. That's going to give me out a 5 either side. Plot all those dots, and that should be your solution. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. And there's my parabola. Also, I want you to notice that this one right here is a lot skinnier. This one opens wider, and it's because of the 1/2 out in front versus the 3 being out in front. So your domain for all of these functions should be -infinity to infinity. That means all real numbers. Your range is always going to be k to infinity if we open up, and it's going to be -infinity to k if your graph is opening down. So for the domain and ranges above, we're going to have all three of them have domains of -infinity to infinity. So you can go ahead and write that down for all three. Now my range for 1 and 3 up, so it's going to follow this first form right here of k to infinity. So if we look back at number 1, my k on number 1 was a 5, so the range is going to be 5 to infinity. Sorry, and I should have put, these were brackets right here. I should have put a bracket around the k. A bracket means the number's included. So we're going to do 5 to infinity. 3 follows the same form here, so it's going to be 3 to infinity. And number 2, remember, open down. Right here is a negative in front. So this is going to be the other form. We're going to use that 4 still, but it's going to be -infinity to the 4. All right, so if they want you to write something in vertex form, and they give you the vertex and a point, you're going to use the formula from above. So that's what we're using, the y equals a x minus h squared plus k. Your vertex is always considered your hk. We're going to use the point as x and y to find our a. So the 2 is going to go in for x, and the negative 5 is going to go in for y. And we're going to plug that in and solve for your a. So we're going to have negative 5, so if we don't know our a value, x is 2, minus my h is the 1, and the k is a 2 there. So this right here is 1 squared is 1, so I have negative 5 equals 1a. I don't have to write the 1, but I did. Minus over your 2, my a is negative 7. So now that I know my a and my hk, I'm just going to plug it into the formula. Y equals negative 7, x minus my x point squared plus my k. Let's try one more of these. So again, that is my h, k, that's your x, y. We're plugging it into the formula right here in all these spots. So we have y equals, we don't know our a yet, x minus my h, it becomes plus because it was, sorry, minus a negative, so minus a negative 3 plus my k. So that's 4 squared, so that should be 16. So 16a plus 6 minus your 6 over here, divide your 16. So a equals negative a half. So I have my a and my vertex and plug it in. Y equals negative 1/2. X minus your negative makes it plus, and then plus your k. Did it.